All right, so today's main agenda is configure and managing the virtual storage in VMware vSphere environment, where in this module, we are going to talk about the available different type of storage options that we can configure on VMware vSphere environment and how we are going to provide the storage to your ESXi host and primarily to the virtual machines that we are running on the top of ESXi host. All right. So this module primarily will talk about the different type of storage components, concepts, and different type of available storage that we can configure in VMware vSphere environment, fiber channel storage, iSCSI storage, what is VMFS data store, what is NFS data store, then what is the vSAN data stores. All right. So again, as I said, I will not emphasize more on the slides today. The primary focus would be to discuss and just to give a do a lot of whiteboarding around that. All right. So when we talk about the storage to be present my ESXi hosts, they would be present in the form of data store. Okay. So when we say data store is a placeholder for your virtual machines, files, snapshot, ISO images, and all. And different type of data stores are available, like VMFS, that we say VMware file system, network file system, vSAN, and vSphere virtual volumes. All right. So any kind of data store here can be a VMFS data store, can be a NFS data store, can be a vSAN data store, or can be a vSphere virtual volume. All right. So when we say the different type of flavors to attach my ESXi host, so the primary storage we refer as an DAS. DAS we called as an direct attached storage. So the DAS storage primarily considered as available local disks in your ESXi hosts. Those are primarily used for uh, installing ESXi hypervisor itself, all right? And any kind of SAN could be your fiber channel or Ethernet or iSCSI. They would present as a LUN. LUN stands for logical unit number. It means that all these three are the categories of SAN storage. Somewhere we will going to connect the remote storage to ESXi host by using different storage fabric technologies. It could be your fiber channel over Ethernet, or iSCSI. All right, and then we use the VMFS is nothing just an presenting it is actually NFS. It is a typo here. NFS. So NFS will be given in a form of a file share, again by using remote NAS servers that we call NAS, network attached storage. And another family is vSAN. vSAN is again a category of direct attached storage, but that is a aggregated. When we say aggregated, is a collection of available multiple disks on multiple ESXi hosts. And another form, data store can be present as a vSphere virtual volume that use the fiber channel or Ethernet storage fabric, and that's present as an storage containers on my ESXi hosts. All right. Yeah, we are going to discuss too much details. Don't worry about that. So let us see some of the features differences in different type of storage. When we say a data store present as an VMFS, so again, my storage protocol could be fiber channel, FCOE, iSCSI. So these all features being support boot from SAN. When we say boot from SAN, if a ESXi host is diskless and we want to present a remote storage even for installing the ESXi, so that concept is called boot from SAN. Rest of the feature kind of vSphere vMotion, moving VMs from one host to another host, vSphere high availability, vSphere DRS, that these all features being supported all family of storage. When we say the NFS, from features perspective, NFS support all the features except boot from SAN. Boot from SAN is not possible through NFS because NFS is present kind of a file share already that is formatted by some file system. Yeah, for DAS is support vMotion only, but yes, DAS direct attached storage cannot be used as a shared storage because of that's a dedicated storage. Then vSphere virtual volume, it's again not support boot from SAN, and again for vSAN it is not support the boot from SAN environment. For rest of the features being supported by vSAN. So well, so if we talk about the VMFS, so any of the data store is presented, it is a shared, you could see number of hosts are there. This is my shared data store. When I say shared data store, when any storage present on number of ESXi host and we format that by VMFS, then it's called the VMFS data store. So it support the concurrent access of multiple hosts, dynamic expansion, on disk locking. When we say on disk locking, it means that if a VMC storage is presented by one host, then it cannot be presented by another host. So VMFS 6 4K native is a block of storage it store in 4K size, 4KB that we called, and automatic space reclamation. When we say reclamation, if any of the disks like virtual disks being deleted on virtual machine level, that automatically that is removed from the data store as well. So NFS data store is present by some NAS server. When we say NAS, it is a formatted storage already. It's present as a file share to all my ESXi host, and NFS being supported version 3 and 4.1. These are the supported protocols. And when we say vSAN, vSAN is just an aggregated pool. As I said, the available local disks on each and every ESXi host will be aggregated in a logical volume, and that logical volume we refer as vSAN data store. So the available local disk could be hybrid. When say hybrid, the flash and cache drive and the capacity drive, it could be flash and HDD, flash HDD, or all drives could be flash. We are going to discuss too much detail, don't worry about that. It's just an overview. So virtual volume is present by the technology that we called as vWall, all right? And it's, yeah, definitely it support all dedo, decompress or encryption feature in backend. And this, again, this is a placeholder of my virtual machines data that is being created here. It is virtual disk, virtual machine file, or so on. And Yeah, it could be present as a SAN LAN or NAS, as a SAN or NAS storage, as a container, and it's a dynamic. The bad advantage of using virtual volume is to like, for example, if in case we need to increase a virtual volume size, so we don't need to coordinate with the storage team because it's a dynamic container. Like for example, it's 2 GB here and we want to increase 1 GB. I don't need to request any to this. It is dynamically expandable. All right. So RDM is a concept where we do present my available storage, underlying storage on the ESXi host directly to my virtual machine instead of by formatting any of the file system. Okay, that's a concept of RDM. You will directly access the file system. That is a simple concept. First, your host will be connected to storage as a virtual disk. But when we say RDM, it will it doesn't require any file system format. It will create a mount point, at least mount point, and my a roll would be present as a disk to my virtual machine. That's we called as an row device mapping. So the use case of row device mapping is like, for example, we need an high-end storage, which is required the high IOPS to the VMs that require equivalent to physical storage, so that Roland can be present directly to my virtual machine. That is called as row device mapping. And yeah, it could be shared to among number of virtual machine. So for presenting the Roland to the VMs, it required in between just a mount point. It is just a FivMB file, and it will represent to my virtual machines directly. Yeah, so while we do the storage uh, requirement, we have to consider what would be my LAN size, data store size, what is IOP size required, what is cache disk, zoning masking, LAN ID, it is active or standby, or NFS data stores. So all these considerations we have to keep in mind. Yes, so this is the detail we are going to talk here, how my fiber channel or FCOE storage works in case of we are presenting the 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 SAN storage. SAN have the different families, so let's understand it one by one. So for what all things we have to do for SAN. But yeah, before SAN, I would like to take you a step back about the direct attached storage. So when I say direct attached storage, it means that we are talking about the available local disks in my ESXi host. Okay. So the primary purpose of available local disks to install the ESXi hypervisor itself. So what you need to do in this case, some of the times we just make a group of the disk and convert these into RAID volume for redundancy purpose in backend. So during the installation part, these RAID volume, just like for example, here I take just for example is 256 GB disk and another 256 GB disk. But when we will apply rate, this rate could be applied from physical host booting process or go to BIOS, or if you are on remote access ID rack or ILO of the server and configure the rate, and this will present as a single logical volume of 256 GB while you are installing. However, during installation, rest of the disk will be presented, but you are not going to use like for this example, we are taking this. So during the installation, my hypervisor will be installed here as an underline. All right. So when you will browse somewhere this ESXi UI console, you will go to storage option. That time you will get one data store that is being created by default during the installation, and data store size would be 256 GB. If in case we have some available free disks that we didn't use during the installation part or we have not configured, so these disks will be available as a raw disk in a storage device section. But if you want to use them again to create some of the data stores, you can leverage them. All right. But all these data stores that you have configured will be present only locally. Let's, for example, this size is 256 GB, 256, 256. This 256 in backend made of two disks. In backend, it is made of only one disk, and it is made of only one disk. Okay. So if you will say, sir, can I use in clustering environment or somewhere? Answer is no, because these are only local disk and present to local ESXi host. All right. Are we clear so far? Any question? Yes, no? Any response, guys? Are you hearing me?
Sir.
Good. Cool. So now let's talk about the SAN storage. And in SAN, we have the different flavors. All right. So when we talk about the storage area network, that's a remote storage. That could be your FC SAN, FCOE, SAN Fabric, and iSCSI. So these all are your storage protocols. So let's talk first about the FC SAN, how this topology made and how you make the request to the storage providers to get an remote storage. All right. So in this case, first of all, you have to, definitely you will install your ESXi host. Number of ESXi host you are using in the cluster. It could be 1, 2, 3, 4, 5, 6, depends upon your cluster size. So for making the FC fabric, each ESXi host will have separate type of adapters that we called as an HBA, host bus adapter. All right. So each host will have the HBA adapters, and this HBA adapter have a unique identify number that we called as worldwide name, WWN. Okay. So this WWN number will make of WWNN node name and WWPN. So from where you will get this information? That's available when you will go inside your ESXi host, inside your hardware, and from remote console, ID rack or this, you will go to the details and then you will get the details of HBA WWN number. Each HBA adapter have this identity on any of the host. All right. So this is This is required for us to share the details to the storage team. Then these HBA will be connected to the storage switches. These are my storage switches. For redundancy purpose, we have to use two storage switch, and this storage switch will be connected to your storage fabric or your actual storage. That storage again will have the storage controllers. So storage controllers are nothing. These are the kind of your uh, servers. They will have the storage operating system. So for redundancy purpose, we are using two. We called as an SP, storage processor as well, or storage controllers. Same thing, right? Each of the host have two storage system will have two storage controllers for the redundancy purpose. And same way in storage switches, there would be lot of FC ports are available. There would be lot of fiber channel ports are available. Same way here, when I say FC port, these are my HBA port. So my topology will be designed in this way just to receive the redundancy. One is here, one is here, one is here, one is here. Same way from storage switch to your controllers. There would be always a redundancy to make the high available paths. All right. So being an vSphere administrator, what you need to do, you just need to share the WWN details for each HBA adapter to the storage administrator. Then what would be the task of storage administrator? Because it is here is no TCP IP. Okay. Each and every device is identifying to each other with the HBA numbers. All right. So now it is a turn of your storage administrator. What storage administrator do? Storage administrator will create the zoning. ZONING, zoning. What is the meaning of zone? Zoning means is storage administrator just mapping all source WWN numbers. When I say source are my ESXi host to the target WWN numbers. So who is target? Targets are my storage controllers. Okay. So it means it is creating a logical path. Physical path is already available so that this storage controller can identify, or these WWN numbers can be present to my storage controllers. Right? This is a relationship, the logical path being created by the storage administrator. All right. So as a next step, what storage administrator will do, a storage administrator will start to doing masking. Masking, masking. Masking. What do you meaning by masking is? So being an storage administrator, it have the power to use the underlying physical disk in my storage boxes, and yeah, converting them, like it will make a group, like for example, it just pick a disk, a group of 10 disk here, apply the RAID 1, RAID 5, whatever policy is required, and a new logical volume will get create where the storage policy is being applied. And from this volume, let's, for example, this is my new volume and that size is 10 terabyte. Out of this logical volume, it will start to cut the smaller chunks. So like, for example, one chunk is 2 terabyte. So this chunk is called as an logical unit number. Like maybe another one, 2 terabyte. That's all headache of storage administrator. All right. So being an vSphere administrator, you will say to storage administrator, hey mister, I want 2 LUNs with 2 TB size on all my ESXi hosts for the details of WWN number I have shared with you, right? So what it will do, what storage administrator will do, he will receive your request over the mail or whatever communication channel is available. So he will mask. Masking means just associate. He will create a group of source and targets, and to this group he will mask these LUNs. Once he will mask these LUNs to the source and target group, source and target means is source WWN number and target WWN numbers, then these 2 TB LUNs will be present here. Be present here. But still, once you will rescan your HBA, refresh your storage, you would be able to see here, because once you will get in confirmation, boss, I have given you the LUNs, and you will see 2 TB row LUNs. When I say row, means that is not formatted so far. So as a next step, from any of the ESXi host, you will start create new data store. Once you will click on create new data store, you will get multiple options there. It is a SAN data store, or it is my NFS. So in case I am using SAN, so it will present when I will select SAN data store. So it will show me the available row LUNs. I will select the respective LUN that need to be formatted. So you will select that, you will format that, and now this row LUN will become as a data store for you. And now it is shared, but you don't need to format it again and again from desktop the host. On desktop the host, you will go ahead and just rescan the storage. Once you will rescan the storage, it will be present. All right, so that's the way of how my FC SAN being present on the ESXi host as a shared data store. Are we clear? Any doubt in this overall process? What would be your responsibility being as an storage administrator? What would be the job, being an vSphere administrator, and what would be the responsibility of storage administrator? All right. Are we clear on it? Anyone have any question? Please let me know. The only thing, you have to provide the details of WWN numbers to storage administrator. Once he will say, yes, I am okay, go back to your ESXi host, rescan your HB adapters, and provision the data store from any of the host, and just rescan to rest of the host. This LUN will be present as an vSAN data store. All right. Are we clear?
Yes. So WWN number is divided into two parts, WWNN and WWPN.
Yeah. That's a 12-digit hexadecimal number, right? So the same thing which I told you, this is my storage controllers, these are my FC switches, and these are my host. All right, same topology is there. Only the difference here is we can make a redundancy. We can give the sorry, it will come here and it will come here for the uh, path redundancy between your storage processors and your FC switches. That's what I was explaining to you from WWN number perspective, 64-bit on FC switch. This is a single way topology. So first have WWN numbers, switch level it will do zoning, and on the basis of request, the LUN will be masked to the respective WWN numbers. All right. Yeah, this is multipathing for the redundancy purpose. The same topology, I just draw a diagram when I was telling you it is for maintaining the path failure and also the load balancing. Okay, load balancing means is whenever storage is required here, it could go via this path or via this path also. Again, for load balancing, there is multiple mechanisms are available. So first of all, from storage side, if these controllers could work as an active or active and standby mode, right? So when we say load balancing, there is one mechanism is round robin. When we say round robin, in round robin mechanism, whenever the host required storage to provide the VMs, sometime it go from this path, sometime it's go from this path. It's a random. It will check the it will check the paths. It will check the requirement and the load, and also all my processors, my storage controller should be active states. Then next mechanism of load balancing is most recent used. When we say most recent used path, it means is like, for example, my host is accessing storage via this path. All right. So whenever a new request is come, new request is simply if some VM is trying to writing a data, that's considered as a new request. It will always prefer the most recent use path. It will always give the preference to this path. All right. And for example, if this got failure by XYZ reason, maybe next time it will choose this path. Okay. And this HBA come back after some time. It will not fail back automatically because again, it will give the preference to most recent used path. When we say fixed is another mechanism. Fixed means is path is fixed, like if from this host any of the VM is writing the data and I have set it as fixed, so it will prefer only this path. Okay. So by any chance, if this path got failure, okay, it will do a failure to another one. So in case of fixed, they will do failure. No. Fixed is always a preference path. If in case it will go to failure, then it is failure. All right. So normally people keep it as MRU, most recent use, because in most recent use, you will get always failure also. So these are the load balancing mechanism, and also the actual load balance happen in round robin only. MRU and fixed always use one time, one path. But yeah, if in case path got failure, they will fail out. So in case of FCOE SAN, FCOE is equal to your FC, that's nothing. But yeah, the adapter you will use on ESXi host, that will have the converged network adapter. When we say the converged network adapter, it supports both type of protocol, FC and Ethernet. When we say FC and Ethernet, it means that there would be a single physical adapter that will have the capabilities of network, Ethernet protocol and FC. It will have converged, okay? But in that case, my traffic will go to fiber FCOE switch. In case of, I would say, FCOE switch, this switch will have the different flavors of ports, FC as well, the FCOE port, FC port, and Ethernet port. So from this FCOE port, it will receive the traffic on FCOE port only. Then this switch will segregate the traffic. Whatever traffic is going to Ethernet port to my LAN, it will use the Ethernet port. And whatever traffic is going to my SAN, it will use the fiber channel ports. The traffic segregation will happen from the host. My traffic will come single cable, but actually the traffic segregation will happen on FCOE switch. All right. We clear on it? So again, this is the single one, but actually making the redundancy. Again, there would be one more FCOE switch, and there would be two CNA adapters available on each and ESXi host, like the way one go here, second will go here. And again, the traffic will go to FC SAN and your LAN. Traffic segregation happens here. So when I say FC SAN, it means that is from this switch to, again, there would be two switches comes in picture. Like this, those would be my storage switches. And same way, if I'm going to LAN, there should be two network switch available. So yeah, same way from these two, redundancy purpose, one cable will go here, 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 like the way. All right. So we can use FCOE as well. But yeah, in FCOE, there is one more layer of networks comes in picture. That is your fiber channel over Ethernet switches. From these switches, traffic will be segregated. But yeah, rest of the technology and terminology will be same to present the FC. So like we are presenting some FC storage. So we are going to use this FC fabric. Further, like my zoning will happen here. And again, from here, there would be storage controllers. And masking will happen from the storage controllers. So any live example of it? If you would like to take any live example, I means that where we use, have you heard about Cisco UCS? Anyone? Cisco UCS. Cisco UCS is kind of hardware servers. So so those servers come as an converged network adapter. They will go to FCOE switch, primarily we called as fabric interconnect modules. And from fabric interconnect modules to further, my traffic got segregated into fiber channel switches and core networking switches. All right. So in case of we are using FCOE for NICS purpose, like we want to connect the any NAS storage. So in this case, we have to create a VM kernel port and map to that the actual physical adapter. Because my FCOE is a converged, it can treat as a the single port can treat as a FC port. If it is a FC port, it will go to FC storage and we have to follow same concept, zoning and masking. But yeah, it also support the Ethernet. If my storage is somewhere NAS, so NAS storage will be achieved through the IP fabric. All right. So in this case, that need to be configured, and FC have an HB kind of your WWN numbers and all. But if we are using as a Ethernet, we have to assign an IP address. So from here, we can make a software defined adapter and we can map to my FCOE network adapter. All right, we clear about FC storage, FCOE. Any doubt so far? Yes, no?
I'm not able to understand this.
Yeah, tell me where you got the doubt.
No, whole thing is like I'm getting confused.
Where? From where you got confused? I'll take from that point.
This one, so this the 24 slide.
FCOE. Okay, all right. So what's being said in FCOE? So normal example, in my ESXi host, there is separate NICs are available for Ethernet and HBA is available for storage. All right. But when I say to any of the ESXi host, a CNA is converged network adapter. So a CNA have the inbuilt driver for fiber channel as well as for your Ethernet. Okay. Now let's take an example. You say, sir, with this CNA configuration, I want to connect FC storage. So what will happen? Because both are the CNA, so they will go to, these are my FCOE switch. When I say FCOE switch, again, they have the adapters that support both type of protocols, fiber channel and Ethernet. They have some ports which support both. They have some port which only support networking. They have some ports which only support FC. These are my CNA. These are my Ethernet. And these are my FC. Okay. Now let us suppose you are saying, sir, in this environment, I want to connect the FC storage. So this CNA from each host, it will go one here. All right. So far from here to here, this is carrying both the traffic, FC plus Ethernet. But now from here, it will segregate. It will segregate Ethernet to Ethernet and FC to FC. So now if we have these FC switches available, these are my storage switches. Now this segregation happen. One FC port will come here, one will go here, one will come here, one will go here. All right. And this is, let us suppose, your FC SAN storage. These are my storage processors or controllers. Then again, it will go like the way. But now if you are saying, sir, with the same environment, I want to access the NAS. NAS means is here. Till now, what I am getting from this topology, whatever storage will present, that is as a SAN LUN. That LUN will be further formatted as a data store, VMFS. All right. But now you are saying, sir, With these kind of environment, I want to configure my NAS. So in this case, these are my, this time these are my FC switches, FC fiber channel switches. Now these are my simple network switches that support the Ethernet protocol, and this Ethernet will be connected here the same way from here, and the NAS storage would be available. All right, but this time all these are my TCP IP. When I say TCP IP, for each of the adapter, I have to configure TCP IP setting. When I say TCP IP setting, assigning IP address. Each of the port will have its own IP address. So this is my pure Ethernet fabric. All right. So now this NAS from this network attached storage, any storage I will create here. So now there is no funda of zoning and masking. It is a simple. It will create a files here, like for example, my NAS server name, back share name. So it will create a chunk of a file share. Let us suppose it's a 2 terabyte. From this host, how I will search it? So now instead of searching a LUN and all, creating data store and all, no, create a data store. This time you will select NAS, NFS. When you say NFS, it will ask you the target server details. And this share, once it is connected, everything is fine. This will be present here as a NFS share. So do you need to create a data store from LUN? Sorry, from this share? No, because it's already formatted by a file system. All right. So in this way, my FCOE can work as a converged network adapter, which can be useful to access any Ethernet level of fabric and the FC level of fabric. But yeah, somewhere in between, we need a converter. Converter means is a kind of switch which support all type of protocols. So this FCOE switch have converged network adapters, and it have the FC and Ethernet adapters as well. One second. All right, Shiva, are you clear now?
Yes, sir.
Okay, cool. Thanks. Thank you for your response. Right, so next family of storage is iSCSI. iSCSI use iSCSI protocol, but this time terminology is a bit different as compared to connecting FCSAN or FCOE SAN. So in case of iSCSI, my topology will be almost same. Again, these are my ESXi hosts. These are my iSCSI adapters. These are my iSCSI adapters. When I say iSCSI adapter, these are special kind of NIC, but it support iSCSI protocol as an storage. They are they are written in that way. Their ROM is written in that way. There is iSCSI protocols is also involved. And yeah, so there could be your special iSCSI adapters available. So what happens in that case? Again, topology would be almost same. These are my storage devices, controllers, and for redundancy purpose, we can make it dual path. But here, my adapter, the iSCSI adapters we are using, no WWN number. They have different number. That's we called IQN numbers. Okay. Same way, like each source adapter will have its IQN number, and each target adapter will have the IQN number. Do we need to do any zoning here? Answer is no, because this time my source host will call to target IQN number. All right. So as an underline, it will again follow the same step. It will use some storage, RAID and all, and it will cut off some of the LUNs. So first time you need to call, and this LUN will be present here as an, again, this call should be made by all the ESXi host as a row LUN. But yeah, then he will format it by the file system VMFS. Okay. But in iSCSI, there is bit more tricks actually. When I said tricks, iSCSI source, a source iSCSI could be a NIC that support directly iSCSI protocol, or can be a simple NIC. When I say simple NIC, it is just a Ethernet. So in that case, we can make software-based iSCSI adapters, and we can map to my physical NICs. These are simple Ethernet NIC, no iSCSI protocol being written inside them. We can use in this iSCSI SAN also. So like here, you could see a target will have an IQN number, all right, and an IP address or IP address, okay. Same way, a initiator will have IQN number or an IP address. So always a initiator will request to target. When I say request, it will try to find out the target by IQN number or by the IP address. But as I said again here, whatever adapter I am using, it could be a physical iSCSI that directly support, or it could be a NIC from where we will configure software defined NIC and we will assign that. So there is three families of initiators. I will start from here. The first type. So the first type of iSCSI, this comes as an iSCSI HBA. All right. It will have inbuilt iSCSI initiator capability. It means that somewhere IQN is inbuilt. It will have the TCP/IP offload capacity. We can configure all TCP/IP addresses here. And yeah, so a iSCSI HBA driver is inbuilt in your VM kernel. When I say HBA driver, where is the driver? Driver is itself inside your ESXi host. All right, this is a one card, but for supporting this, my software driver is inside my ESXi. That is the first. Second level of card come, like this is not a HBA, this is NIC. When I say HBA, my cable connectivity will be fiber channel cable. When I say the NIC, supported iSCSI initiator, this, but the NIC driver and iSCSI configuration is inside my ESXi VM kernel. Okay. And third category, you say, sir, I am not able to invest too much money to purchase HBA, to purchase the iSCSI NICs separately. Any other solution for me? Can I use my simple NIC? Yes, that's also possible for you. It is your simple networking topology, no separate storage switches. Okay, no separate fabric. So it is your simple network card. So in this case, my network driver, my initiator service, my TCP IP offload, that all will be taken care by your ESXi host. Okay, we clear? Any doubt of all these three adapters type? Yes, no, any answer? So here we need to produce the initiators also. So what I will do in this topology, let us suppose you have a simple Ethernet card. This is the simple Ethernet card, no iSCSI driver, nothing. So what you need to do, you will first create a iSCSI VM kernel port, and to this iSCSI, because this VM kernel port will treat you as a iSCSI port. To this iSCSI VM kernel port, you will assign an IP address, and this will be mapped to your network interface card. Okay. At this time, I have created a virtual iSCSI adapter as an VM kernel port. I have give all the identities, IP address, IQN will all be available, because all these things need to be done on ESXi host level, and then that will be mapped to my simple NIC. So this is my simple network topology, simple network switch connections and all. Okay, but yes, we should not mix and merge with the traffics that we use for kind of for management vMotion VM kernel. Like yesterday we were using two uplinks, right? In networking configuration, we should not use that. All right, we clear? And in this case, my initiator capability is available in my NIC, that is specially iSCSI NICs that we bring from the market. But yes, so TCP IP offload is available, and this NIC driver is here. So we will directly give the initiator and TCP IP configurations to my NICs. All right. We clear on three types of adapter? Yes, no?
Yes, sir.
Okay, so if you have good budget, you want good performance, then iSCSI case, you bring HBA and make separate topology for it. When I say separate topology, it means that there would be separate switches that will be used for storage purposes. All right. And this is my iSCSI storage. But if in case, sir, I don't have too much budgets and all, I want to leverage my existing setup and all, take it and just use your simple. Now, these are not my any FC switches, or these are your simple network switches you will use. Okay. But as I said, these traffic should not be merged with another networking traffic that you use for production environment, like virtual machine or management, vMotion or other stuff, right? There should be a dedicated NICs available that primarily we are using for the iSCSI connectivity. Got it? We clear? Yes, no? Suresh?
Sir,
Siva, Suresh, are we good? So don't need to be afraid too much, because we are not going to use each and everything. So most of the environment, there is FC storage, but yeah, for concept perspective, we should be pretty much clear. like the way he showcased. Yesterday you were asking Siva where we use these is VM kernel. So one of the VM kernel we are going to use for the iSCSI connectivity as well. All right, that's another function of VM kernel port. All right, so this is just, it is showing you an example. The example which I gave you, you have to create a iSCSI adapter software defined. In this case, we are not assuming my adapter have the capabilities for iSCSI initiator. So we are taking this example, right? So what is being created here? First, you will create a iSCSI adapter. It's a virtual, all right? And this iSCSI adapter, this is the software defined base software adapter. This will be mapped to the actual NIC somewhere. Probably you could see here, physical NIC mapping. And to initiate the traffics and all, I can give not directly IP. I will create a VM kernel port and I will associate with this. This will be associated with this NIC. In that way, in backend, this NIC is just only transferring my information. This will have an IQN number as an iSCSI initiator. Initiator is always my requester and target is my from where we are putting the request, and where we will give the IP. The IP will give here VM kernel. All right. So in Hindi we say it's a jugaad. Do you guys understand jugaad?
Yes,
Suresh?
yes, we are Indians.
Huh?
Yes, sir.
We are Indian.
No, I'm asking from Siva and Suresh.
No, sir, I don't. You guys, what it means?
It's a temporary, it's a kind of, it's a kind of temporary solution. By hook or crook, you have to configure, right?
Oh.
So in North India, jugaad is a device actually. It's a kind of vehicle where people just take parts from different things. A electric engine, tires from different thing, and make the body for different things. Then we combine it called as a jugaad.
Oh.
All right, so that's outside. So here, as I said, like a initiator will always send a request, but don't get confused. It's never, it could be HBA, it could be NIC as well. All right. So this request will go to target, and whatever the target will have, that would be presented to my ESXi host as a Rollins, and that would be further configure as a data store. So it's, if we want to make an additional layer of authentication, we can make that. That is the chap or something. So that's a redundancy topology. Same with 3 example here. Software or dependent adapter, where we are using normal NICs. iSCSI independent hardware adapter, where you could see this is my independent. It means that I don't need to configure too much about iSCSI, VM kernel port, software. That's all being, sorry, in this case, that's all being available already. But here we have to configure the iSCSI based software adapter, map with the network interface card, then assign IP address to the VM kernel port. So all these 3 things comes together equals to a single iSCSI HBA. That's have already everything is inbuilt. But here, a VM kernel port, a iSCSI adapter, then my simple network interface card. Yeah, that's an example it is showing you. That's how we access the iSCSI storage. So once it is available, then it could be present as a data store. A data store size could be, limit is 64 terabyte as of now. Right, so how we'll create data store? Right click, new data store. Then yeah, you will go for searching the iSCSI one or an FS1. Then sorry, FC or iSCSI, it will present as a roller and just format it as a. So these are the LUN IDs. So we will select any of the LUN. Like for example, we have select this one. So this will present as a data store here in the data store section. What we could do data store, we can store our VMs, upload some ISO file, download that, create folders, that all task we can perform in the data store. So now just an example where we need to increase or decrease the data store size, what we need to do in that case. So while, for example, if today you have an data store of 2 terabyte, now from as a vSphere administrator, you say, sir, I need 1 more TB space to increase my data store size. How an storage admin can do for you? So the first thing, a storage admin will provide you a new 1 TB data store, sorry, a new 1 TB LUN from the backend. You will start to increase your data store, and there you will get a new LUN of 1 TB, and you are going to merge that with it. All right. So merging of 2 LUNs for me as a single data store would be equals to 3 TB. All right. That technology is called extend when we are merging 2 LUNs. There could be another way. A storage admin will say, like now you have 2 terabyte, you require 1 more TB. A storage admin, what a storage admin will do from the backend, it will increase the size of existing LUN itself plus 1 terabyte. So you will go ahead and you will start increase, and you will see the free space size, but with same LUN ID. Okay, you will select the same LUN ID and your data store will be expand from 2 terabyte to 3 terabyte. So expand is nothing, just storage admin is just expanding the same LUN, and you are using the you are increasing the data store size by using the same LUN. And extending means is you are extending data store with 2 or more LUNs. If in case from the backend, storage admin don't have the capacity to increase the same LUN, he will assign the new LUN, and you are going to merge these 2 LUNs. Once is existing one and the second one is the new one, and that's present as a single increased data store. All right. Are we clear so far? So there is some option unmount. Unmount is nothing. If you want to unmount from all the host, unmount, but data store data is safe. But if you will delete, then all my data will also be deleted. When I say data, it's my VM configuration files, data files, image files. Okay, that's all will be deleted. But can we unmount the data store from single host? That's also possible. All right. But if we'll unmount from storage section, it will be unmounted from all the host. We can mount it back. My data will be safe for the time being. But if I will delete, the entire thing will be deleted. And this, for now, it is data store. If I will delete it, it will go back as a row LUN. When I say row LUN, there is nothing. You have to reformat it back and you have to present it as a data store, as a fresh. If there is a number of things you have deleted, there is nothing, it is a row LUN. You have to again format it as a data store. But if you will just unmount it, everything is there. That's only it is disconnected from your ESXi host. You can mount it back. Can I unmount or mount the data store from single host? Yes, that is also possible. All right, be clear? That's multi-pathing. That's we have already discussed how it works actually. So we can make different kind of multi-path mechanism that we already discussed with you. By default, it is MRU, but if you want to change, we can. Create VMFS data store, expand and all. That lab we are going to perform with iSCSI storage solution that we have a software-based solution we will create within lab itself, right? So our next target is to perform the labs around creating and all, but in actual environment, you don't need to do anything on storage boxes. But here we have a software defined storage kind of software that will present as an storage to your ESXi host and present as a LUN. Then we are going to do all activities, creating LUN, deleting, mount, unmount, expand and all. All right, guys, that's it from my side for today. Next, we will cover NAS and these vSAN, probably next section. Are you guys available tomorrow?
Sir, let's schedule on Monday.
All right, no problem. Till then, you please went through the videos, what we have done. And Shiva, we already also have one more recording. But yeah, the same thing is repeated today. You can go ahead with that as well. Right, so Monday we are going to perform the lab, whatever we have done so far.
Sir, are you going to remove the recordings tomorrow, or it will be there for some time?
Yeah, please download them. My 1 second, just
Please keep for 2-3 days more.